Hello. Well, today we're going to be talking about vectors and how to work with them mathematically or using algebraic skills. The other day we talked about how to work with them graphically by drawing them and measuring them with a protractor and ruler. Today we're going to be using a lot of our algebra skills. What you're going to specifically learn how to do is how to break down vectors into their x and y components and then add them together. The first example here is we're going to just break this down, this first example, into its x and y components. And we talked a little bit about this in class, but let's look at our first example here. If we had this vector says it's going 400 meters per second at 25 degrees north of east. So I've got this vector, and we're going to say it's 400 meters per second at 25 degrees north of east. Well, down here, this has both x components and y components. And what we mean by that is, as well as going up, here's where we started and here's where we're at now. Well, this vector here shows us that we've traveled up and we've traveled to the right. So up, we say it has y components, and because we're also to the right now, we said it must have had x components as well. So how do we break that up into its x and y components? Well, we use some of our algebra, and it may have been a while since we've used this, but I've got a right triangle here, and if I come out of this angle, this is my opposite side, this is the adjacent side, and this is the hypotenuse. And if I want to break this down into its x and y components, what you're going to find out is the y component corresponds to the opposite, and the adjacent side corresponds to the x. So if I wanted to break this down into my y component, I basically want to know what is the length of the opposite side given a 25-degree angle and a 400 meters per second long hypotenuse. Well, this takes us back to our trig ratios of SO, CA, TOA. And I'm going to use my opposite and the hypotenuse, which is the sine function, the SO part here. So I would say the sine of 25 degrees equals the opposite, which is y, over the hypotenuse, which is 400. Okay, what we've done here is I multiplied both sides by 400, and what that gave us then was 400 times the sine of 25 is equal to y, or our opposite side. So my y component here is 169 meters per second. And what that means is, as we're traveling along this vector at 400 meters per second, we're also traveling in the y direction at 169 meters per second. So every second that goes by, I would be 169 meters higher than what I originally was. We would go about solving for the x side, or the adjacent side. Well, what two sides do I know? I know the hypotenuse. I want to find the adjacent, so that then turns out to be the CA part, or the cosine. So we could say the cosine of 25 degrees equals the adjacent, which is the x, over the hypotenuse of 400. What we find out here is I multiply both sides by 400, and we get 400 times the cosine of 25 degrees equals x, or our adjacent side. We're going to find out the x component. So as we're traveling at 400 meters per second at this angle, we're also traveling in the x direction at 362.5 meters per second. Every second that goes by, we're going to be traveling in the x direction at 362.5 meters. So 2 seconds would be about 725 meters I would have covered in just the x direction. Okay, what I've done here at this point is I went ahead and drew this new vector. I've drawn a picture of it up down here at the bottom, and What we've done with this as well is we've located that this right here is our adjacent side, which is our x, opposite, which is our y. I want you to go ahead and pause it here and see if you can't work it out. Find what the x and y components are. Okay, in this problem here, I've given us the sine of 35 degrees is equal to y over 125 because the y, in this case, is the opposite. I know the hypotenuse, so I want to use the sine function, the so part of it, and we solved for it, and it gives us 68.8 meters. The cosine is what I'm going to use to find the x. As we said, the adjacent almost always aligns up with the x, and we can work it out that way so that it always does. The cosine function then is cosine of 35, x over 120, because it's x over the hypotenuse, which is 120. In that case, turns out to be x equals 98.3 meters. So what this means is our displacement, we started out here, and we are now 90, even though we are 120 meters from where we started, we are 98.3 meters in the negative x direction, and we would talk about this being negative or positive. We don't have a sign over here because we haven't at this time designated the right being positive and the left being negative. That's always up into interpretation. We do it that way because we've been taught that way, but it doesn't always have to be right is positive, left is negative, because it depends on which way you're looking at it. So hopefully you're able to do a good job with that. Okay, hints to solve projectile problems. Typically, you're going to want to draw a picture. Hopefully we've gotten into that happen. We're going to make our list. All right, here I say identify all the givens. That's our list of what we want to get done. Break into its x and y components. Usually that's going to be speed. And then use our kinematic equations appropriately. If it's horizontal ones, use x's and a's. If it's vertical question, use our y's and g's for the most part. Okay, here's a problem. I've already gone through the first step of drawing a picture. Now, what I'm going to do next is I'm going to break this down into its x and y components. This is our x, this is our y, and that's going to give me my horizontal velocity, because this is the velocity it's heading down, but that's not just, that's got a horizontal aspect to it, and it's got a vertical aspect to it. So it's going down, and it's going, I have it drawn going to the right. You could have drawn it going to the left. So its horizontal velocity is going to be what I find to be x. Its vertical velocity is going to be what I find to be y. So I'm going to do that. So what I've done here is I've went ahead and found what its x component is. Its x, or its horizontal velocity, is 173.2 meters per second. Its y velocity, or its vertical velocity, is 100 meters per second. Now, it's going down, so we would probably dictate this to be negative 100 meters per second. It says, how long till it crashes? Well, we want to know time. So you ask yourself, out of your four kinematic equations, which ones give you time? I've listed the two equations here that give us the time. The top one, all right, uses velocity final, initial velocity, gravity, and time. According to this, I know what its initial velocity is going to be in the y direction. Its initial velocity is negative 100 meters per second. It's going down, so what do we know? It's going to accelerate. It's going to keep going faster and faster. I know gravity, but I don't, I guess we don't know its initial heights. We know nothing about how high it is. How long till it crashes? I don't know that we can find this. Sometimes teachers put questions on here that are just bad questions. I guess we're going to leave it at that. I'm a little bit shocked and surprised, but hey, we'll have that sometimes. The important thing here is that we have learned how to break it down into its x and y components. So if you look back at our objectives for the day, we got that done. I'll see you on the flip side.